All right, so this is Quiz A of Chapter 12. These are all the various types of sampling methods. So we're going to look at them and see what we can figure out. Okay, so we know sampling method-wise, let's go ahead and start with this. The best is a simple random sample. Simple random sample, everybody gets the opportunity to be selected, sorry. Everyone has the same probability of being selected. Doesn't look very good. This is the best. This is also called an SRS, and yes, you can abbreviate that, and they understand what you're talking about. The other type, census. The census means we ask everyone in the population. We ask the entire population the question. Then we have a convenience sample, which is the worst. But it means it's convenient. We stand outside, we walk outside the door and ask the first 30 people we know. We go to the cafeteria and ask them about whether they like to eat lunch in the cafeteria or not. I mean, it's a simple thing, it's an easy thing, but this has the most error to it. You know, sometimes it is convenient to do it and we need to do it, but it's not the best possible choices. All kinds of biases occur with that. And then we have what's called a cluster. This is where we select an area or a group, a section, whatever it might be, and we do a census of that group. So hopefully you see the alliteration of census and cluster. So simple random sample is best. That's where everybody has the opportunity. We can do that. Random number generator, everybody assigned a number, put everybody's name in a hat, stir it up, put everybody's name in a bucket and stir it up, however it might be. Census is asking everybody. Convenience is a convenient thing to do. Cluster is selecting an area or a group or some type of thing and doing a census of that group. We can also, we divide people up by strata, and that's called a stratified. But then from a stratified sample, we randomly select from the group. So a cluster is we could pick everybody in Miller's Crossing and do a census. Or a stratified would be to select Miller's Crossing and randomly select homes from there by generating their numbers, somehow randomly selecting homes or people to choose from. Okay, now last one is called systematic, which sounds just like it's spelled. Systematic, you have a system of like doing every fourth person or every 10th person. You have a list of names and go certain ones, or every fifth person that walks through the door. That's a systematic function. Sampling, sorry. So here we go. So let's look at these and see how we can define these. There are 4 ranks of students. So we've put them in a strata. There are 4 ranks: freshmen, sophomores, juniors, seniors. Then we randomly select from each class. Okay, randomly doesn't mean it's a simple random because we take 15 from each group. Not everybody has a chance. So this is a stratified random. Also, some people would call this, I'm sorry, I've gone absolutely blank. Stratified. Stratified random. Some people call this multi-stage because we divide by stratum and then do a random selection. Okay, randomly select a class rank and then survey every student in that. Well, that's a cluster, which is a kind of a multi-stage. We randomly select a group, and then from that group that we've selected, we do a census of that group. Every student means a census. Give every student a 9-digit number, and then randomly choose 60 numbers. That is a simple random sample. And then here on this one, using the class roster, select every 5th student. Every 5th student. So that's a systematic sample. Okay, explain why the second plan above, sampling all from one rank, might be biased. Okay, that's from this one. Sorry, do a cluster. That is called undercoverage. Not everybody from the entire school has the opportunity to be selected. Okay, that's undercoverage. Now let's look at this. So we list 20 names of these juniors. Using a random number, select 5 of them. We're going to select 5 of them. And clearly explain your method. Okay, so our digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, obviously that's not, we can't do a single digit for each person, and we don't want 2 people to be 0 and 2 people to be 1. That's not logical, nor is that random. So instead, there are 20 people, so we need 20 numbers. And to do that, we're going to have double digits. So we're going to do double digits. Sorry, let me adjust this just a little bit. We're going to do double digits. And we're going to go 0, 0 through 99. Okay? We need 20 of those. That's 100 different people, 100 different choices, but we only need 20. So what I'm going to do is do 0, 0 through 19. No, not 20, because 0 counts. 0, 1, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that's 20. And I'm going to ignore 20 through 99 and any repeats till I have my 5 people. So here we go. So starting right here, I do 0, 4. Oh, I got to number them first. Here we go. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, and Stacy is 19. So here we go. 0, 4 is Chris. So we're going to select Chris. Let's see. Then 0, 2 is Joy. 85 doesn't count. 52, 59, 81, 18 is Paul. 3407 is Rachel. Let's see, 54, 60, 20. Whoops. Oh, we didn't do 20. 90, 67, 65, 27, 30, 62, 83, 70, 82, 66, 98, 32, 36, 70. Wowzers. Oh, there we go. 06. 06 is Kenny. Of course, he's going to die by the end of the show. And there we go. There's our 5 people we would select. Okay, so down here it says, name and describe the kind of bias that might be, if she just randomly selecting, instead of randomly selecting, she just asked students to volunteer. Okay, that's a voluntary response bias. Only those who feel strongly about something will answer. Okay, and gives the survey during class one day. That's undercoverage. Not everybody gets the opportunity to be asked. I know, my spelling's atrocious. It could also be a response bias, because those in the class may respond to how they think the teacher wants them to respond. Okay, so there's that. Boy, that was a long video. Hope you have a great rest of the day.